Hello there! Today's lesson is on kinetic theory. At the end of the lesson, you should be able to state the assumptions of the kinetic theory, explain the molecular structure of solids, liquid, and gases using kinetic theory, distinguish between boiling and evaporation using the kinetic theory, state the factors that affect evaporation. Before we get into what kinetic theory means, let's go over the meaning of matter and energy in different forms. Anything that has mass and occupies space is called matter. Matter is made up of atoms and molecules. Electricity, light, and heat are forms of energy. These forms of energy neither take up space nor have weight, but they are not matter. Nevertheless, energy and matter go hand in hand. Electricity as a form of energy is closely related to an atom, which is matter, whereas heat is the kinetic energy of molecules, which again is matter. According to the kinetic theory, every substance that is solid, liquid, or gas consists of a very large number of tiny particles called molecules. Molecules are the smallest particles of a substance that can exist in a free state. Molecules possess the characteristic property of the parent substance. Molecules are in a state of motion with all possible velocities. The velocity of molecules increases with the rise of temperature. The velocity of molecules increases with the rise in temperature. Molecules always attract each other. The force of attraction of molecules is called intermolecular force of attraction. The empty space between molecules is called intermolecular space. The intermolecular force of attraction increases if the intermolecular space between the molecules decreases and vice versa. We will now look at the molecular structure of solids, liquid, and gases on the basis of kinetic theory. In the case of solid, the intermolecular distance is small, and hence the forces of intermolecular attraction are large. The only motion permissible to a molecule is the oscillation or vibration about its position, which is fixed. Hence, a solid has a definite size and shape. In a liquid, the molecules are further apart than the solid. The molecules are free to move about within the volume of the liquid. Hence, the liquids have their own size but no shape. In the case of gas, the intermolecular distance is larger than that of a solid or liquid, and the molecules of gas are free to move about in the entire space available to them. Hence, gas has no shape or size. Now, we're going to explain some phenomena on the basis of kinetic theory. These phenomena are melting, boiling, and evaporation. Melting is the process due to which a solid changes into liquid state by absorbing heat energy. The constant temperature at which this process occurs is called melting point. 1. On heating a solid, the closely packed molecules gain kinetic energy and start vibrating vigorously. 2. This results in an increase in intermolecular space, decreasing intermolecular attraction. 3. At a setting point, molecules become free and the solid starts changing into liquid state. For example, ice changes into water at 0 degrees Celsius. Boiling is a process in which liquid changes into gaseous form by absorbing heat energy. The constant temperature in which a liquid rapidly changes into gaseous state is called boiling point. 1. On heating the liquid, the intermolecular space increases, thereby decreasing the force of attraction between the molecules. 2. The molecules become free, acquire more kinetic energy, and move randomly in all directions. Liquid can slowly change into gaseous form at a temperature far below their boiling points. This process is called evaporation. During evaporation, the molecules gain energy from the surroundings and start moving faster. When they get enough energy, they escape into the atmosphere, leading to evaporation. With what we've learned so far, you should be able to differentiate between boiling and evaporation using the kinetic theory. Can you? Give it a try then. Evaporation depends on the following factors. 1. Nature of the liquid. Liquids like methylated spirit evaporate rapidly, while others like glycerine may not evaporate at all. 2. Temperature. The higher the temperature, the greater the evaporation. 3. Pressure. The lower the pressure exerted on the liquid, the quicker the evaporation. 4. Dryness of air. If the air is dry, the evaporation is greater and more rapid. Damp air hardly makes evaporation possible. 5. Surface area of an exposed liquid. The larger the area of the exposed surface of the liquid, the greater the evaporation. 6. Relative humidity. At high humidity, the rate of evaporation is lower, but at low humidity, the evaporation is comparatively high. We have now come to the end of today's lesson. We stated the assumption of the kinetic theory of matter, explained the molecular structure of solids, liquids, and gases using the kinetic theory. We also learned about some phenomena such as melting, boiling, and evaporation on the basis of kinetic theory. And lastly, we stated factors that affect evaporation. See you in the next lesson.